L'Hopital's rule is used when finding the limit of a function results in an indeterminate form. Indeterminate forms arise when the x value that the limit approaches results in 0 over 0 or infinity over infinity, for example. There are 4 simple steps you can follow when using L'Hopital's rule. First, you want to start off by directly substituting whatever x value that the limit is approaching into the function to see if it will result in an indeterminate. If it results in an indeterminate, you have to apply L'Hopital's rule by taking the derivative of the numerator and then taking the derivative of the denominator. Then you can evaluate the limit with the function that you just generated from taking the derivative. Whatever you get is the limit as long as it's not an indeterminate. If you still get an indeterminate, then you have to continue taking the derivative of every derived function until the answer does not result in an indeterminate.
Okay, today we're going to be focused on polynomials, and as we have one right here, ax squared plus bx plus c, and all these are terms, as you can see right here. Ax squared is the leading term, and c is the constant term, and we'll be solving a polynomial using L'Hopital's rule, and this is the problem we're going to be solving. And we're going to have 3x squared over x, and then we're going to do the same thing we do at the top, we're going to do the bottom. So using this rule, we're going to have this up here. Same thing to the bottom. And then from here, we're going to differentiate. We're going to find the derivative of both the top and the bottom. So we're going to have for this 3 and 2, it's going to be 6x. And for the bottom, it's x, that's going to be 1. And bring it back down over here. We have 6x over 1, which is just 6x. So we just write it as this right here. And then from here, we're going to want to transform the expression. So we're going to have 6 times 0x. We're going to substitute the x for a 0. So we're just going to have 6 times 0, 0. And then we have our solution right here.
Here is an example of where L'Hopital's rule can be applied. To evaluate the limit of 3 tan x over 4x as x approaches 0, we have to directly substitute 0 to see if L'Hopital's rule can be applied. When 0 is plugged into the function, it results in 0 over 0, which is an indeterminate. Now we have to take the derivative of 3 tan x and the derivative of 4x. This will give us 3 secant squared x over 4. We can substitute 0 into this now. And when we substitute 0 into the function, we get 3 over 4. So the limit as x approaches 0 of the function 3 tan x over 4x is 3/4.
Hello everyone, today we'll be going over L'Hopital's rule. I have this problem right here. The limit as x approaches 0 from the right, x times the natural log of x. And using direct substitution, we know this is 0 times negative infinity, which is the indeterminate form, so we can use L'Hopital's rule. I'm just going to rewrite this question as the limit x approaches 0 from the right, ln x over 1 over x. And how I rewrote this question is because we have x times the natural log of x, we can just divide it as long as we get the reciprocal of x. So I got the reciprocal right here, 1 over x. And using direct substitution, we know this will be negative infinity over infinity, which is still an indeterminate form. So now we could apply L'Hopital's rule. Here is L'Hopital's rule. And finding the derivative of natural log of x will be 1 over x over negative 1 over x squared. Now we could just simplify this, and we will get limit x approaches 0 from the right of negative x. And now using direct substitution, we get negative 0, which is 0, and that is the final answer.
Here is an example of question that results in an indeterminate form, but we can use L'Hopital's rule to solve it. This question has an exponential function as limit x approaches 0, e to the power of x minus 1 over x squared plus 3x. When evaluating this limit, this would normally give us 0 over 0, but we can take the derivative of the numerator and the denominator instead. So the derivative of ex is ex, and the derivative of 1 is 0. The derivative of x squared is 2x, and the derivative of 3x is 3. Now we can plug in 0 to solve. E to the power of 0 over 2 times 0 plus 3. Which gives us e to the power of 0 is 1, and 2 times 0 plus 3 is 3. So the answer is 1/3.